Hello everybody. So over here we are going to discuss 5 important questions on the chapter polynomials. So let's start with it. So you see this type of question can come. I mean it has come in previous year questions many a times. So let's try doing this. So for what value of k, minus 4 is a 0 of this polynomial. So suppose this polynomial is p of x. You see the variable is x over here. Although it's not mentioned, but obviously you have to take x to be the variable. So it is given that minus 4 is a 0 of this polynomial. So therefore you can say that p of minus 4 is equal to 0 because minus 4 is a 0 of this polynomial. So in place of x we can put minus 4. So you'll get minus 4 square minus of minus 4 minus 2k plus 2 that is equal to 0. So let's solve and simplify this. So you'll get basically 2k plus 2 that is equal to, this is 16 plus 4 20, and if you solve it you'll get k is equal to 9. So this is a simple question and it can be asked in MCQs in your board exam. Let's try doing the other thing. So various combinations of zeros of quadratic polynomials can be asked. I have discussed many a times on the Infinity Learn Class 9 and 10 YouTube channel. Let's do 1 or 2 more questions on it. For example, you have got a quadratic polynomial given like this. Suppose it is 2x square plus 3x plus 7, something like this. And suppose the zeros of this quadratic polynomial are alpha and beta. And suppose they are asking find the value of alpha square beta plus alpha beta square. So this is one of those questions. You can have many questions on the basis of this topic. So over here, the very first thing is they will give you a polynomial which you will not be able to factorize, which you will not be able to split using middle term method, splitting the middle term method. You can obviously find its zeros, but if you will directly try to put alpha and beta, it will make it very complex. So try to find the expression in the form of alpha beta and alpha plus beta. So take alpha beta common over here, you will be left with alpha plus beta. Now you see alpha beta is what? That is equal to c by a if you remember, and alpha plus beta is minus b by a if you remember. Now c by a is what? Constant term divided by coefficient of x square. So that is 7 by 2, and then b is the coefficient of x. So minus 3, and a is the coefficient of x square. So that is equal to minus 21 upon 4. So this is the answer. In the same manner, they can ask other expressions as well. For example, they can ask to find the value of alpha square plus beta square. So whatever is the expression, try to change that expression in the form of alpha beta and alpha plus beta. You have to manipulate it many a times using identities. So you see over here, this can be written like this: alpha plus beta the whole square minus 2 alpha beta, minus 2 alpha beta. Then you know the value of alpha plus beta, it was minus 3 by 2 over here. So just put the value over there, minus 2 into alpha beta, you also know that is 7 by 2. C by a is 7 by 2. And then obviously you can simplify. So these are 2 examples of questions like that. Now you see in the same category another type of question is there when alpha minus beta is given many a times. It's an important question from your board point of view. So obviously you don't have to find alpha and beta separately. You can change the expression over here. You can just square on both the sides. I can square on both the sides. You see that is 1 square. So over here this can be written like this: alpha plus beta the whole square minus 4 alpha beta. You can just simplify using algebraic identities, and this thing will be equal to alpha minus beta the whole square only. Now you see over here, alpha plus beta is what? Minus b by a. So that is equal to minus, b is what? Minus 5, the coefficient of x. So minus 5, and a is nothing but coefficient of x square, that is 1. So the whole square. Then minus 4, c by a over here is what? K by 1. That is equal to 1. So you just need to simplify and solve it. This is 25 minus 4k is equal to 1. So if you solve it, you'll get k is equal to, you see 24 by 4 is 6. So that is 6. So k is equal to 6 is the answer. This is one of the important questions on this topic. Let's move to the next important question. So you see, if one zero of this polynomial is reciprocal of the other, you have to find the value of a over here. So 1 0 is reciprocal of the other. So whenever you get a question like this, that 1 0 is reciprocal of the other, so it means if 1 0 is alpha, the other 0 is 1 by alpha. So in this case, just take product of zeros, and that is equal to c by a. You know this thing. So you see, c will be equal to a. So when 1 0 is reciprocal of the other 0 in case of a quadratic polynomial, the constant term is equal to the coefficient of x square. So you see over here, the coefficient of x square is a square plus 9, and the constant term is 6a. So you can just simplify. You'll get a square minus 6a plus 9, that is equal to 0. So if you use identity over here, this is nothing but a minus 3 the whole square. So you see, this is only possible when a minus 3 is equal to 0, or you can say a is equal to 3. So that is the answer. Now one more type of question can be asked many a times, that 1 0 is negative of the other. 1 0 is negative of the other. It means if 1 0 is alpha, the other 0 is minus alpha. So whenever you get a question like this, take sum of zeros. 1 0 is negative of the other, take sum of the zeros, that is minus b by a. For a quadratic polynomial, sum of the zeros is equal to minus b by a. So you see, this thing is equal to 0 only. So if you just cross multiply and simplify, you'll get b is equal to 0. So if in a quadratic polynomial 1 0 is negative of the other, then coefficient of x square will become equal to 0, and then you can do questions accordingly. I'm not saying that it is being asked in this question, but it can be asked. Now the last category of important question in this chapter is finding a quadratic polynomial. Now you know that there are infinite such quadratic polynomials whose zeros are these things. I have discussed it many a times in the class. I did prove it as well. So quadratic polynomials whose zeros are alpha and beta can be written like this: k into x square minus sum of zeros into x plus product of zeros, right? Where k can be any non-zero real number. So they can never ask the quadratic polynomial. That is not possible, because there are infinite such quadratic polynomials whose zeros are alpha and beta. But if they ask a question like this, you can just assume that k is equal to 1, because you just have to answer only one polynomial in that case. So I'm just taking k is equal to 1 for the time being. So the required polynomial will be what? X square minus sum of zeros into x plus product of zeros, So 3 plus root 5 multiplied by 3 minus root 5. So you see, this will be cancelled out. So from here, this will give you x square minus 6x. Over here, you can use a plus b, a minus b identity. That is 3 square minus root 5 square. So this is 9 minus 5, 4. So x square minus 6x plus 4. Just check it once again. So this is one of those polynomials whose zeros are 3 plus root 5 and 3 minus root 5. And these are the important questions in the chapter polynomials. Obviously, you have to practice many more questions, but these are one of the most important questions in the chapter polynomial. That's all we needed to discuss over here, guys. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. Thanks for watching.